All right, let's do our next to last segment here in the lab. I've got the sine wave at 1 kilohertz and 2 volts peak to peak. The RMS is 715 millivolts. RMS is just another way of measuring the effective power in a signal, and it's used widely in the power industry as well as communications. So the scope calculates it for you for convenience, and the peak to peak though is the amount of voltage from the very top to the very bottom. For a sine wave, you'll learn in circuits class or somewhere maybe, the RMS is actually the peak value, the 0 to peak value divided by the square root of 2, in case you're wondering. So when we talk about 120 volts at our wall outlet, for example, the peak value is actually closer to 170 volts. But anyway, so what we're going to do is we've got that voltage applied now to save you from having to watch my clumsy handheld video jiggle around a lot. I already made one of the connections. So the function generator is connected to the resistors. Okay, you can see the negative and the positive. And I connected channel 1 of the oscilloscope to the exact same terminals. And that's what the lab asks you to do. So what we're seeing on the screen is what's being applied to the circuit. Okay, so now what we're going to do is take channel 2 and measure across the lower resistor. We're going to measure across this resistor. And the way we do that is the same way as channel 1, except we don't have to duplicate the ground, because this little ground clip, this clip right here, is actually internally connected to the ground clip on channel 1, so they're both exactly the same. There's no need to double connect them in the circuit. It won't hurt anything, but it just saves you a little bit of fuss. So what I'm going to do is connect here, and I could have connected here just the same because they're connected to each other. Now, I don't see anything on the scope, and the reason is I had turned channel 2 off before, so I'm going to push this in to turn channel 2 on, and there's the blue waveform. And you can see it, the shape looks the same as the yellow, but the size is different. Okay, well, that may or may not be important, because the thing we don't know right now is what scale each of those are set to. So you have to look down here to see what the scale is. And for channel 1 is 500 millivolts per division. That's half a volt per each one of these divisions. And for channel 2, it's the same. So actually, these are on the same scale, so you can compare them with each other directly, and you can see that the blue is about half of the yellow. Now, that's just eyeballing it, but if you want the actual numbers, the scope calculates it, and you can see it's the same frequency, but now the peak-to-peak value is about 1 volt, which is half of the yellow. And that's what we'd expect. From the voltage divider law, these are equal resistors, so each one of them should be getting about half a voltage. So that's confirming our suspicion. And what the lab asks you to do then is to write down the RMS value of those and take a screenshot. All right, so we're going to go ahead and finish off here by replacing one of the resistors with an LED. They're labeled in the circuit diagram. R1 is the one closest to the positive side of the function generator. R2 is the one connecting to ground. So in my circuit, this is R1 because it's connected to the red, and this is R2 because it's connected to the black. All right, so we're going to place R1, this guy right here, we're going to place it with an LED. See if we can make some lights blink. So let me go ahead and turn off the function generator. Okay, so everything goes to 0, the circuit's dead. It's safe for me to go ahead and disconnect, and I'm going to do that as best I can. There we go, disconnect that, and disconnect this. Pull this resistor out, and I'm going to walk over and get an LED. they're in a drawer that's marked LED. So I'm going to grab any one, should do fine. I'm just going to grab our first red one I can get my hands on. Actually, it didn't turn out to be a great one because it's got pretty bent up legs, but I think we can make it work. Anyhow, this is, you notice that one of the legs, I'm sorry, my thumbnail is terribly dirty, I just noticed, and that's because I've been working with some cleanup chemicals here in the lab. But anyway, ignore that. One leg is long, one leg is short. The long leg is positive. LEDs have a positive and a negative, and so you have to be aware of that. You want the positive leg to come in or to be closer to the positive of the supply. Now, because I can't do this with one hand, I'm going to end this video segment and then pick up right where I left off.